When considering the Earth's atmosphere, we note that the Earth's atmosphere is really a very thin veil of gas that surrounds the planet. It's held close to the planet because of gravity. We're going to take a look at the structure of that atmosphere because the structure of the atmosphere helps us understand many things about how things happen in the atmosphere. The atmosphere is a very dynamic, changing, interacting entity, system, if you want to use that word, in and of itself. The heating of the sun, currents in the ocean, the effects of land masses all play a role in affecting the atmosphere. When talking about the structure of the atmosphere is considered to be layered. The two layers that we really talk a lot about are the troposphere and the stratosphere. The troposphere is very close to the Earth. The stratosphere is the next layer just above the troposphere. Troposphere is sometimes nicknamed the weather sphere because about 99% of all weather that impacts us as humans and life on Earth occurs in the troposphere. Only very occasionally, the biggest thunderstorms on the planet may peak their tops into the stratosphere. The stratosphere is really important for us on Earth because it does some functions that protects us and protects all life on Earth. It's the home to an ozone layer. And looking at the structure of the atmosphere from the ground up, let's take a look at these layers and why these layers exist. If this is the Earth's surface, we move vertically through the atmosphere. The first layer that we encounter is the troposphere. The troposphere is an area of high density of molecules. Many pollutants are trapped within the troposphere. Troposphere is also home to a lot of the weather on the planet. The next layer vertically that you'll encounter in moving vertically through the atmosphere is the stratosphere. The stratosphere is less thick less dense as far as air molecules than the troposphere, but it's also home to a very important sublayer called the ozone layer. The ozone layer helps shield life on Earth from ultraviolet radiation from the sun, which is why it's an important component of AP environmental science. Above the stratosphere is the mesosphere. In the mesosphere, temperatures are changing, density of air molecules is much less, and above the mesosphere is the thermosphere. You can see the suffixes of sphere in each of these. Sphere meaning circular shape. But what are these layers based upon? If you were in a rocket ship moving up, say in the space shuttle, riding up through the atmosphere, would you see a sign as you passed from the troposphere into the stratosphere and another sign when you left the stratosphere and the mesosphere? Are they different colors? Are they visible to humans? Not necessarily. They're based on characteristics. The layers of the atmosphere are divided by temperature. As we move through the troposphere, temperatures decline systematically. They reach a point at which a temperature inflection point occurs and temperature of the atmosphere starts to increase. That point at which the temperature starts to increase identifies the beginning of the stratosphere. As temperatures continue to increase through the stratosphere, we eventually reach a point where temperatures start to decline again. That's the end of the stratosphere and the beginning of the mesosphere. As the mesosphere temperatures continue to decline, we eventually reach a point where the temperatures start to increase again. And that increase identifies the end of the mesosphere and the beginning of the thermosphere. And temperatures continue to increase as we move out of the atmosphere. Between each of the layers of the atmosphere is what's called a pause, P-A-U-S-E. Between the troposphere and the stratosphere, it's a tropopause. Between the stratosphere and the mesosphere is a stratopause. And between the mesosphere and the thermosphere is a mesopause. Interestingly, as we move up in the atmosphere, atmospheric pressure declines very systematically. This is due to gravity. Gravity holds and hugs the densest air molecules close to its surface, while as you move away from the planet, only the lighter gases remain. because they have less mass, therefore are not held as tightly as gravity. A few years ago, a man named Felix Baumgartner actually jumped out of the stratosphere. I've placed on a diagram the approximate height at which he was at when he left his capsule. He rode in a balloon into the stratosphere and eventually jumped out and parachuted back to Earth safely. It's one of the highest jumps ever, thousands and thousands of feet up, 25 miles to be exact. He needed a complete suit to protect him from the cold and lack of oxygen at that height. He also was very close to the ozone layer. The ozone layer, again, protects us from ultraviolet radiation.